This is the setup for the experiment. So we have here the eye model, and it includes usually the retina screen, the aperture, and different lenses. Some of them are concave and convex. It depends on if it's a positive focal length or a negative. You can see this one is positive 307 millimeter, and some of them are negative. There's a negative 1000. Negative 1000 millimeter. And some of them are cylindrical, and the cylindrical ones are the ones that has these two edges. This one basically has these two slots. It means it's a cylindrical lens. And we have adjustable focal length lens. Okay, this one. Eye model stand, ruler, protractor, and a light source with an object, a bucket filled with water. I would say between 1 to 2 liters of water, clean water. Then we have the optics pinch. So this section has multiple stages that we are going to do. And basically, the purpose of this section is to simulate the eye's accommodation process by adjusting the focal length to focus on objects at varying distances. So let's start. First, we need to do the initial focus setup. So basically, we will place this stand for the eye model, and we put the eye model on top of it. We have the retina screen on the normal position. We will put our source object, and we will make it on number 4. So we have it here. And basically we will put a lens of plus 400. The plus 400 one lens. This is the lens of plus 400. I'm not sure whether you see it or, yeah, I hope you see it right now. We will put it in the septum slot here. We will turn on the light source, and we will adjust the distance. Then we will adjust the distance until we see a good image on the retina screen. See it here. So we will move, basically I am moving the light source, approaching, then I'm going to go further away. So I have kind of a focused image of the number 4. Flipped one. So this is a very focused version actually of the number 4. I would say here would be, at this location would be the best and the most focused number 4. This is basically the new distance. As you can see, they are far from one another. So now we would like to fill the eye model with water to simulate the eye's humors. Okay. And we will look at the retina screen to see whether the image is still in focus or not. Okay, so let's see. Let's zoom in on the eye model and see what happens in this case when I fill the water itself. So putting the water. I'll turn off the light so that we can see better. So you can see that the image is almost completely gone. So now we will do some adjustment for the near vision to see the things or objects that are close. We will make the distance between the source and the light and the eye itself around 35 centimeters. So I'm going to push this one close. Let's say this one is going to be at 70. Okay, this is 70 centimeters. I will push this one to be around 35 here. Okay, so this is approximately 35 centimeters, which is near vision. Okay, then from here I will replace this lens, the 400 plus 400 lens, with another lens, which is basically the 62 millimeter lens, plus 62. I'm not sure whether you will be able to see. Okay, this is better. It's 62 millimeter lens. So we will put it inside the septum slot. Okay, voila. We can see that now with 60 millimeter, it's adjusting for the water effect, and we see that the image is in focus. I hope you see the number 4, it's in focus now. Now let's make the light source as close as possible to the eye model itself, while keeping the image on the retina to be in focus. So I'm going closer. Now it is in focus, not in focus. So I would say the closest distance here, it was basically, the difference was around, basically I moved around 2 centimeters, around 3 centimeters. So this was the nearest point using this 62 millimeter lens. And we will call this one as basically the distance of the object from the light source in our case. So we have the length from the light source to the image, and basically from the lens itself to the retina, which is basically from the lens, this lens, the 62 millimeter, to the retina itself, is going to represent the distance of the image itself. Now, as we said, if we approach the light source to the object, the image that we see here is going to be less focused. So we would like to make some adjustment by adding some lens, or removing, or like basically changing the lens, the focal length of the lens itself, so that we can see the objects at near distance, nearer than 32 centimeters from the eye, the human eye, while keeping basically the 62 millimeter lens. So now I am going to add, let's say we are going to add the plus 400, this one, the plus 400 millimeter lens, and I'm going to put this one at slot P in front of this, the main lens at slot B. You have it here. So now if we look at the image, we see that the image becomes not in focus, and we need to move the light source to get it in focus. So I'm going to approach. So we can see here that we have a perfect image at a closer distance from the eye model, which basically it's around 25 centimeters from the eye model. And we can see actually how near we could go closer to the light source. closer to the eye model, and we still have a focused image. So I would say the closest point, it would be around 24 centimeter or 23 centimeter from the eye model itself. So by adjusting the lenses here, the lens system here inside the eye model, we start to observe closer object from the eye model. Now let's make another change. Let's change the 62 millimeter lens and basically change it with some kind of higher focal length lens. And let's see what's going to happen. Where is the focus distance from the eye model? So I put it inside the septum side. So we see that the image on the retina screen, it's gone. There is no image. So we need to move the light source back and forth to see where exactly the focus location. No, mirror, actually it's bad, it's worse. We have to go, I think, away from the eye model until we see a good image. Okay, I can see a good image here. We need to go away more. It's actually a very good image right now. I see it. I'm not sure you see the... Okay, so let's zoom in so that we can see better the image at this distance. So I hope you see the image itself. So now it is in focus. The four is beautifully focused. And the new distance here, basically by doing this adjustment, we are able to see the far objects. So the distance right now between these two, the eye model and the light source, is around, this is 2, this is 85. So it's approximately 83 centimeters. So the distance here between the eye model, the light source and the eye model, it's 83 centimeters. So now we would like to explore the effect of the pupil that we have in our eyes. And basically we're going to do this with the following. We would like to basically return the setup to the original position. So let's remove these two lenses here and basically return back the lens of 62 millimeter plus 62. We'll put it in the septum slot here. Let's turn on the light. Now let's make the distance that we recorded before, which is, I think it was the near distance was around 34 centimeters from the light source, distance between light source and the eye model. So this was on 70, I think. And this one was around 35. So here we have a beautiful image. Okay, I hope you see it. Beautiful image of the four. Then we would like to put the pupil itself. So this is the pupil that we will be using. We'll put it in slot A. We will put the round one in the slot A. So let me turn off the light. So now we see a sharp image of the number 4. Let's move the light source closer a few centimeters to see whether still we have a focused image or not. Actually, still we have a focused image. Actually, yeah. So now we still have a good focused image. Okay. But actually, we are now the difference, or we are at a distance of 28 So we are at a distance between 28 centimeters, so we are closer around 6 or 7 centimeters from the eye model. So let's see what happens to the image if we remove the pupil itself. See, the image becomes less in focus compared to when we put the pupil itself. See, it is more in focus. And when I remove it, it's not in focus. When I put it, it's in focus. So this is the effect of the pupil. So now we will focus on a distant object. So I will remove this pupil tool. Then we will put this one, the eye model, and let's basically make it to point on the window as a far object. You have it here. So we will see basically this far object, and I'll close the light so that you can see better. So we see here that the image is not in focus at all. Okay, so we would like to change the lens that we have it here so that we get the best image. So this lens was basically, this is 62 plus 62. Let's try the 120 plus 120. Put in the septum slot. Let's see the image. Actually, right now we have a very good image. We did not change a lot of images. So this is a focused image, I would say. Flipped focused image of the window. So now I'd like to simulate the cataract removal and correction. Basically, we will do this by first removing the crystalline lens, okay, which is inside, and we will place at the front of the eye, which basically as if it's the eyeglasses, okay, a lens so that we can restore the image or the distant image that we have. Okay, so I'm going to use the 400, the lens of 400 millimeter. So and on this one, so this one, the 400 millimeter, I'll place it at slot 1, and let's see whether let's see first without the crystalline image. See, the image is basically plotted here without the crystalline lens that we have it inside. So let's see whether we can correct this problem. Basically, it's a problem in the eye that we don't have the crystalline lens. We can adjust it from the outside using eyeglasses. So we put it on a slot 1 here, in front of the eye model. Then let's see the image itself. So we can see that the image is in focus after doing this adjustment. You can see if you remove this lens, it's totally blurred. When we put it, we see a focused image of the window. So let's return back the eye model to the optics bench so that we try to see a near object. So you have it here. Let's see whether we can see this near object or not, as we said. So we don't see any image after returning the eye model. So we would like to move the source itself until we see a better image or like something. So I keep going back and forth to see whether we can see. Sorry, we can see a better image here while putting the 400 millimeter lens. So I think that we see something, okay, at this distance, but it's not that clear. So let's replace this 400 lens with a 120 and see what's going to happen. Anything? You still don't see anything? Okay, so now we can see the image, a very good image at a near distance. So you see here, we have here a very good image at this distance while not having the crystalline lens, but we have a lens of 120 millimeter as if it's an eyeglasses with this light source. I hope you have found this lab beneficial for you. So if you like it, please like and subscribe and share it with your friends. And wait for me for my next video. Thank you.